So I have now gotten 2 units of 1 kVA or 1 kilowatt tertiary inverters, 12 volts. Sorry guys, we're already like 12 minutes into our practical test of comparing a 100 amps lithium battery with a 230 amp tubular battery. The reason is because my cameraman is not around and my phone wasn't recording. I don't know how it happened. So, but we're already 12 minutes into the practical test. This is CWAT 12 volts, 100 amps with a load of about 600 plus watts. This is a 230 amp luminous 12 volts with the same amount of load. Now, the reason why we are doing this is because most installers have said that a 100 amps lithium battery will outperform a 230 amp or 220 amp tubular battery, or they give out the same amount of energy. So that's why we are doing this practical test. Both of them have the same inverters, the same amount of load. Now we are going to use our digital multimeter to check what we are pulling from both batteries. And in this practical test, we are not following manufacturer's recommendation. Yes, we are not following manufacturer's recommendation of draining to this guy to 80%, and we are not following manufacturer's recommendation on this guy of 50% yield. So we are going to go above that or below that. Yes. So we are pulling about 48.4 amps from this very battery, which is a 100 amps battery, the lithium battery. Now, the voltage left in this battery is 12.6 volts. We made sure both batteries were fully charged before we started this comparison test. So we are consuming, let's say, 48 amps, and the voltage is 12.6 volts, 12.6. So that's about 604 watts. That is what we are draining from this battery, right? So the battery is 100 amps. It's actually a 1.2 kilowatt hour battery. That is 1,200 watts of battery. So we are going to divide the 1,200 watts by 604 watts. It should give us at least 1 hour, 50 minutes, or let's say 2 hours, about 2 hours, right? Since it's a 1,200 watt battery, and we are not following manufacturer's recommendation, we are going above the 80% depth of discharge. I've already set the inverter to 11.0 volts so that the battery will go flat. So let's check how much we are consuming from this guy as well. On this guy, we are consuming about, let's say, 52 amps from this guy. The reason is because the voltage on this guy is lower than the voltage on the other guy. So we are pulling more current from this guy than this guy, but they are both the same amount of energy. Let me check the voltage. So the battery is maintaining volt of 11.8. So 52 multiplied by 11.8, that's 613 watts. That's almost the same thing that we are consuming from this very 100 amps, right? So 613, and this guy is a 230 amps. This is a 230 amps, not 220. So we should be able to pull at least 2,760 watts from this battery bank. Now 2,760 divided by 613 watts. It should give us at least 4 hours, 5 minutes. If we will drain out this guy from this very battery, that is the number of hours we should expect from the battery if we are going above the manufacturer's recommendation. So once the system goes off, I'll come and do a final video, tell you the number of hours it actually took us to drain out these two batteries. Remember, the initial video that I did while I started this practical test, the video didn't save, I don't know why, but we started at 4:30, and this is 4:48. So we're already 18 minutes into the practical test. So this is 4:48. 18 minutes into the practical test, and both batteries are still going strong. So let's see the number of hours it will take us to drain out these batteries, or which of these batteries will give up first. So this is 5:37. That is 1 hour 7 minutes after. and both batteries are still going strong. This guy now is maintaining 11.2 volts. This guy is maintaining 12.2 volts. While on the battery screen, we have just one bar left with 12.4 volts. So this is 627. Our tubular battery is still going. Our big boy here has gone off. This guy went off at 6:20. That is 1 hour 30 minutes. I have 11.4 volts. It means it cannot go below this. So the battery has shut down. That's why it's alarming. While our 220 amp tubular battery is still going, but with a voltage of 10.8 volts, because you can drain this battery down to 10.5 volts. I did the setting on the inverter to 10.5. Our battery is still going strong at 10.8. Now, a 220 amp tubular battery will always outperform a 100 amps lithium battery. It's just like having a 20 liters of jerry can and the other one is 10 liter, and you say the 10 liter will carry more fuel or carry more water than a 20 liter jerry can. That is what people have been trying to say all this while. But from this practical test, 220 amp tubular battery have proven that it's actually more than a 100 amps lithium battery. Long-term investments, go for lithium. Short-term investments, go for tubular. Now, the reason is because if you want to be draining the 80% DOD from the tubular battery, the battery might not go up to 7-8 years. That is expected. So it might give you 3 years or 4 years. That is why most tubular batteries die off at 3 or 4 years, because most people consume the battery up to 80% DOD. Now, manufacturers only tell you to use 50% DOD, because if you go above 50% DOD, the battery will no longer give you the 7 or 8 years. That is what the manufacturer said. But the manufacturer never said that this battery is 200 amps. It can only give out 50 amps. That is not what the manufacturer said. The manufacturer is just trying to be on the safer side so that your battery will last longer for you. I mean, it will give you a longer lifespan. The disadvantage of tubular battery is that you'll be carrying out maintenance of adding distilled water or topping distilled water every 6 months or 8 months, depending on the usage. While the disadvantage of lithium battery is that BMS might go bad or BMS might shut down, and you might need external body to keep waking it up. So all of them have disadvantages and they have their advantages. Initially, when we don't have all these 100 amps, 200 amps lithium battery, we assume lithium batteries are expensive, but right now lithium batteries are cheap. But the fact is, a 100 amps lithium battery, any day, anywhere, can never outperform a 220 amp tubular battery. It's not possible.